ويني ما يلقبها يوم ما تكره يوم ما تكره mining says rentic. I apologize, we had some problem with our broadcasting platform. If you are receiving this email, this means you are registered for session 4 Remtech Europe on mining sites. Yes. ኢሜላችን ወስዶ ነው ኢሜል ያደርጉልን ማለት ነው። ማየበት ይላል ከቻች በኢሜል ሲገባ አይ እንትን ነው ኢረር ተፈጥሮባቸዋል።
ملار دولة لكن لا من يسرع أنت وسقودوا هذا الملي
Hello.
ኧረ አንድ ነው።
Got it. Yes, sir. አጭር ስለሆንኩ ነው። ጠጋ ብል እኮ ይወጣል እንደዚህ ዌልካም ሰር አቡሽ
Morning, Abush. Hello. Who is the chair for?
So then we would see again a decrease in the isotope value, because then the
Hello? Hello, sir. Hello, everyone. Who is the chair? Daniel Rasco ഇല്ലമ്മ
Harry. Harry. Harry.
Hello, yeah. Who is the chair? Do you know anyone?
Mary.
Who is chair, please?
Where's your mom? Mary. Listen. Okay. Oi. Nayade. Listen, let me get him job, okay? That's he's working or responding to your reply. He's asking you a question. You can't just go to sleep. You playing game all day. Have you read a book? Come put it down. Yeah.
Yes, mommy.
I also went Jimmy. You can't draw. You don't want to learn anything. I told you, Kwame, you can play, but the first thing you do is you have to read your book.
Yes,
You have work, and I tell you all the time, you don't want to listen. Huh? Isn't it? What Jimmy home? Huh? Because Kwame, you can play. I don't say don't play. But the first thing you do is you do some work. I said, if you try to train you, try to give you the direction, that will help you. You don't want to do it. If you do that, I'll ban you from playing the game, okay? I said, come on, you do, when you come on, the first thing that you read your book, when you're done, who drank that thing?
yes.
Yes? Who did it? Have you finished it? And so why is it sitting here? Now go and wash it and put it back. See, what do you mean? Where's my charger? Where's my charger? Who put all these tissues here? Who's there? Okay, put them in the bin. Where's my phone charger? Oh, this is downstairs. Where's my iPhone charger?
Hello. Hi, I'm speaking to the speakers. Please, hi, Charles. Can you?
Hello, Marco. Nice to see
Hello,
you.
Charles. How are you?
Very good, thank you. Yeah, you're looking good. You must be very busy, tiring day.
Oh, I know. Just a moment, I close the door because it's an exhibition, and every time comes somebody.
Yeah.
Try to share your screen. Very nice,
Okay.
the logo of the University of Newcastle.
Thank you.
Very,
Yeah,
very
try to
nice.
share. Can you see the screen?
It is arriving. Just a moment. Yes, try to put all screen, full
Okay.
screen. And
How's it? Good?
yes, it's working. Go down
Okay, let me
till the
forward a
last
bit.
slide.
Yeah.
Okay, exactly.
Okay, good. All right. Okay.
Okay,
it's good.
Charles, do you have any animation inside
No, no animation. No, just basic
or
slides.
videos?
Yeah. No, no videos.
Charles?
No. Open up the sound. Yeah, no videos. Yeah, it's just basic slides. Yeah, Marco, you are lagging, or maybe I'm lagging.
Hello, Marco.
Hi, everyone.
Looks like Marco is frozen for a while. I can hear the others. Yeah.
Yeah, I can hear you.
Hello,
Charles.
everyone.
I cannot
Hello.
hear you.
Yes, Jared. Yeah.
Hello.
Marco is frozen for a short time. Hello.
I got some
Jared.
animations actually inside the slides. Do you think it will be lagging?
It should work. Depends on the whole internet infrastructure. It's worth a try. Yeah. It's nice to have video, but
Yeah, that's the problem, no? It's a little bit challenging.
you can try it. Yeah. When Marco is back, you can share and try your video.
Oh, good morning, everyone. I'm José Gouveia. I will be the chair of the session. So
Okay.
I suggest for the presenters that we do a test with the slides just to check is everything working.
Okay.
So, Mr. Charles, can you share your screen?
Okay.
Your
Right.
slides just.
Okay. I'm gonna put it on.
Okay. Can you put a full screen mode? Okay. Okay.
Yeah,
Can
good.
you scroll?
I'm gonna forward a few slides. Forwarding.
Yes.
Good.
Yes. Okay.
Okay.
Until the
Good.
last one.
Huh?
Until the last one.
Okay. Go to the last. Okay.
Okay.
Yeah, I think it's good.
Okay. Okay. Thank you. You can stop share. Now, I would like to ask to Mr. Carlos Harty. Mr. Harty isn't here. Okay, Mr. Alberto Angeloni.
Yeah, that's me.
Okay.
I mean, I'm not Alberto Angeloni. I'm Hans Elsa, but Alberto, let's say we present together. I do the lecture.
Okay.
So I'm going to share the screen now. I hope that's it. It's okay. Can you see something?
Not yet.
But if I
You need to share screen in the bottom, the green button.
I do that, but
Okay.
that it doesn't react. I see. Oh wait a moment. I have to next window. Share. No, this one. Share. Now I'm going to do the slide. Now you can see something.
Yeah, yes. Can you put in the full screen mode?
That's what I'm going to try now, because
Okay.
my Zoom is slideshow. 1 second. We're getting. Okay.
Okay. Can you move to the left? Okay, it's working. Okay, thank you.
Okay, now I have to unshare.
Yes.
Stop
Please.
share. Okay.
Stop sharing. Now, Beatrice, can you share your slides?
Yeah. So now I am lost. Okay, share screen. Yeah.
Yes. Okay. Can you move fast to the last one?
Yes, I can. Okay, that's why. That is why.
Okay.
Wait a minute. Sorry.
Thank you, guys. Sorry, I was back. Today is an unbelievable day. Now it crashed my PC, so it's my fault. So it's. I hope, Jose, that you started with the speakers to share screens. Is there anybody missing?
Now we are testing the Beatrice Watts slides. Beatrice, can you move to the last slide, please?
Okay, yes, I believe that you had already seen.
Yeah, we are seeing the first one.
But okay,
Just the first
that's
one.
why.
Yeah,
It's
we need
not,
to
it's
move
not
to.
moving actually.
Yes, it's not moving.
That's why I was seeing the other screen. Okay. What's happening?
No.
It's not moving.
No, not yet.
Wait a minute, I will have to stop this. And probably I will have to start again. Yeah, okay.
Yes, okay, now it's working.
I had a little animation there, you see?
Yes, it's working.
Okay.
Okay, I think now there's Mr. Gerrit Dorland. Can you share your screen? So
Yeah.
Beatrice, stop sharing, please.
Yeah.
Just stop sharing. Okay. Oh, okay. Can you put in presentation mode? Yes, okay. Can you move to the last slide, please?
Yeah, works well. Huh?
Yes, yes, working good. Okay, thank you. Now, Mr. Hernando Simon, can you share your screen? Hernando, are you here?
I don't seem to see him here.
Yes. And Mr. Carlos Errarte?
Yes, I'm here.
Okay, can you share your screen, please?
Yes.
Just to check your presentation.
Okay. Zoom said to me that I'm not available, the function to share my screen with you.
Yeah.
I think you need to some permits for me. I don't have it.
Try now, Carlos.
Okay. Yes, now I can.
Okay.
Thank you.
I think you are in control, Marco.
Yes.
Okay.
But I see that there is one speaker still missing, Hernando.
Yes, Hernando Simon. Yeah.
And I don't know if I cannot see him.
Yeah, we have some minutes, but Hernando is the last one, just in case we can.
Yes.
Yeah.
Yes. In fact, let's see what happened. And but however, in case Jose, to you and to the speakers, we don't have a real limit to Zoom for the last session. We can continue till 7:30 or 8 even, Central European Summer Time, so that we don't have the sudden closing as for the previous sessions.
Okay. Okay. Can you move to the last slide, please? Okay.
Carlos, there is a problem.
Yes.
We see the how do you say, the presenter mode, not full screen.
Yeah. Okay.
And stop sharing and share it again, the full screen.
Okay. I'm going to start sharing you. Now I'm going to share again. I think now share. Now?
Yes, now
Yes.
it's working.
Perfect.
Yes, okay.
Okay, I'm going, if you say from the beginning, we can start and then you can see it. Okay. Right, and then just check. Right.
Okay, right. It's working. Now we are
Thank you.
just missing Hernando.
Yes, I see online also Stephanie Fiorenza and Robert Jelinek. Please, Stephanie and Robert, turn on your camera.
Hello.
And help. Hi, Robert. Hi, how are you?
Oh, fine.
Mining
Hi,
sites
Mark.
are also. Hi, Stephanie. Welcome.
I'm trying to get my camera on.
Mining sites,
being
Robert,
very
are
slow.
also very frequent also in the Slovak Republic, right?
Yes, particularly past activities. So, but we face those problems today.
I've been in Banska Bystrica. I don't know if the spelling is correct, but for the meeting 3 years ago. And the new meeting has been set or postponed.
So,
Carlos, can you stop to share your screen?
Still they are thinking. The situation is changing.
Okay, thank you, Robert. Stephanie, sorry to interrupt you. Welcome.
Hi.
Hi, we can
Thank
hear you,
you,
but
Marco.
we are not able to see you.
I realized this. I had my camera on just an hour ago. I don't know what's going on with it. So let me see if I can get it to send. Or
by the way,
I have an external camera. Let me add that.
Okay, we have still 5 minutes before starting, and you and Robert and Jose would have the keys of Remtech Europe for this important meeting. So I'm sure also the panel discussion will be really, really interesting. Remind all the people that we have, let's say, the discussion at the end. And I don't know, Jose or Robert or whoever who has the timetable to share in the screen.
I have it with me, so if you like, we can try it.
Yes, please share it at the beginning when you introduce the session.
So I first like to introduce ourselves, and then I will skip to sessions.
Okay. Yes, no, but the timetable, the general timetable of Remtech Europe, I mean, not the agenda of today.
So general timetable, I don't have.
It is in the shared folder, our common shared folder. I don't have in this PC, unfortunately, but
I have this extended program.
If you have the program, it's the page number 2. If you have the program, it's page number 2.
Extended program. Yes, digital program summary, you mean?
Wait.
I can try to share it. I try to share it. Can you see?
Just a moment, I'm trying to share it.
Me too.
Yeah, we are seeing the Robert's screen.
Yes, the timetable, Stephanie, please.
I'm trying to get
Yes.
1 second.
Yes, please.
I pulled it up in advance. If I could just get my whole screen open. I feel like I've got too many things open. Here we go. All right, got this up. Now if I can get my screen up.
Don't worry, Stephanie. I've tried. I've found it. Just a moment. I have to
okay, I have it.
Share it.
Okay.
And for the next session, you will understand what I need. Oh, okay. Okay. That's perfect. That's perfect. Don't stop.
Yeah,
Don't
it's
stop
just this
sharing.
is Wednesdays. I just have to get.
That's fine. Okay, go on the
I
first
just have
slide.
to get today's up there.
Yes, go in the first slide so that we
That's
make
what
a
I'm trying
launch
to
also.
do. There we go. Okay.
Okay, perfect. So he's arriving. Not arriving.
It's just very low. There we go.
Okay. We see the second one. Go in the first one.
Oh, I know. Is it still only showing the second one?
Yes, exactly. I don't know why.
Sorry. I don't either, because according to this, I have the first one selected. Sorry.
Don't worry. Let me try to share by myself. That's
okay.
you
Sorry.
are able to see.
Sorry, Marco.
No problem, no problem. It's considering what happened to me today is not such a problem.
Okay.
You can see here the program. We have the situation right now for the situation right now is we are in session number 4. Session number 4 waste tailings and acid mine drainage. Challenges for mining sites, session number 4. Tomorrow at 9 Central European Summer Time, there will be session 5 on bioremediation and phytoremediation, session 6 starting from 11:30 Central European Summer Time on 2 sessions, oil and hydrocarbons impacted sites, and session 7 on high resolution site characterization. Then there will be the protagonist of the Tuesday will be Stephanie, if you want to mention in the afternoon. The session on ASTM standards, PFAS, sediment and climate resilience, session number 8. Then we have also on parallel also the session 9 on innovative digital and smart characterization techniques tools and the circular economy, how to apply it in the context of the next generation EU, session number 10. Okay, that's all from my side. I again apologize for any problems that we had in today. We would have the registration available for all the sessions of today, so that don't worry if you have lost something, you will be able to see it again in our Remtech Europe website. Okay, Hernando, I see also Hernando online. Hernando, we don't have time to make any trial. We will start with the program. So welcome, Hernando, and I will hand out the floor to Jose from Nicole Latin America, Stephanie from STM International, and Robert Jelinek from the Slovak State Geological Institute. Jose, Stephanie, and Robert in this order.
Hello. Thank you very much.
Thank you.
Thank you, everyone, to be here today with us. So I'm José Gouveia. I'm Vice President of Nicole Latin America and the Project Manager of Environmental Liabilities of Companhia Siderúrgica Nacional in Brazil. So we are here with Mr. Robert Jelinek from Slovak State Geological Institute, and Stephanie Fiorenza from ASTM to moderate the session 4. So we are very pleased to welcome those of you had been with us today for this very interesting session. We're going to have 6 presentations regarding waste tailings and acid mining drainage challenge for mining sites. So before we get started, I have some instructions for general organization of the session. So we don't take questions in the end of each speech. Every question is postponed to the final panel. We have some minutes for this. And for the speakers, I also gently ask to keep on time to follow the schedule for the session. So I also like to invite who is interested to come back tomorrow for session 5, where we're going to have a very interesting presentations regarding bioremediation and phytoremediation in agricultural, industrial, and military sites. So thank you very much for listening, and let's start the program with Mr. Charles Lee from University of Newcastle, that will present use of nature-based solutions for remediation and restoration. So welcome, Mr. Lee, and the floor is yours.
Thank you. Yeah, thank you, Jose. I'll share the screen, share my slides now. Before I start, so that you can see. Can you all see the slides and hear me clearly?
Yes.
Yes, thank you. Yeah, it's quite amazing technology, although we have been doing a lot of Zoom webinars, but this is so global, it's exciting. And thank you for the organizers, Jose, and quite a few that I can't remember the names, and to have the privilege to present the first paper on use of nature-based solutions for remediation and restoration. Marco is kind to have me start, I think, because I'm with University of Newcastle, Australia, but I'm based in Singapore. So it's about slightly past 11 p.m., getting a little bit sleepy. So I hope I can stay through the whole session. This overlaps with session 5, as Jose mentioned, that is bioremediation and phytoremediation tomorrow. What I'm gonna talk about is, let me give you the outline. What is nature-based solutions? You must have heard about this term increasingly so within the last, a few years, and the power of nature. And I'm just going to focus on, given the limited time, on phytoremediation using plants to uptake metals in a contaminated site. It's an agricultural site, and it links back to mines because unfortunately they have been using the mine drainage as agricultural water for decades, and using a hyperaccumulator plant to uptake the metals, some results, and moving forward. Now, nature-based solution, I have one slide. I mentioned remediation, which we are intimately in for this conference, and restoration. Basically, nature-based, biological-based systems, nature ecosystems are so powerful. Inherently, it locks in the capability to remove and detoxify toxic chemicals in the environment. So we are harnessing, nature. For example, as I mentioned here, plants. We'll talk about phytoremediation, probably not new to a lot of you. There are thousands of species available. And the other part on restoration, which I don't have time to cover, is basically restoring damaged ecosystems. And we are in the decade of ecological restoration from United Nations Environmental Program, basically replanting mangroves that are heavily being damaged from urbanization in coastal ecosystems. Also work on degraded peatlands, especially in Indonesia, from burning to plant oil palm plantations. And we are replanting native peatland vegetation to restore the peatlands back to something that is usable. We focus on the phytoremediation in this presentation. We'll move you quickly to China. Hot topic in Guangdong province is a very large province, southern part of China. You must have been to Hong Kong. You cross over at Shenzhen, where Dongguan, where most of your phones are made. Now, we will go to the northern part. The northeastern part is where all the mines are. They've been around for hundreds of years, very old mines, and we have lead, zinc, and cadmium contamination for a long time. The other metals that we find are in the Pearl River Delta. They're mostly from industrialization. So we're moving up north where the old mines are, and also where there's agricultural fields, unfortunately. So in China, it's estimated that at least 1/5 of the agricultural lands are contaminated, land and water, from urban waste streams, from irrigation back in the 1950s. And the Provincial Department of Environmental Protection says about 30% of soils exceed the Chinese national soil quality for lead and cadmium. Very, very serious problem. For this case, we are looking at hyperaccumulator plants. For those who are not familiar, they are, I'm gonna move this thing here so I can see my slide, about basically able to accumulate about 100 times more metals, for example, than the non-hyperaccumulator plants. So if one was to select these plants, they do not die from toxicity, but can uptake it. and a lot of the species belong to the Brassicaceae family. Again, when you test the shoots, the dry mass zinc, manganese, you have as high as 1%, which is 10,000 ppm of these metals, and 0.1% to 0.01%, very, very high concentrations, but yet the plants are surviving. So these are really amazing plants, you know, that's given by God for us to use. And this particular Sedum alfredii is a fern type of plant that is used in our remediation. It was found in the, it's a mining ecotype. So when we went to the mines, they are acclimatized to the high concentrations, excuse me, and it's grown over in the higher kind of regions, as you see here, native to China, Japan, Korea, in the moist forested slopes, 2 to 30 degrees, quite a range of temperature and elevation. Originally found in the Zhejiang province, Zhejiang province is just next to Shanghai. Way back, the mines have been operating for 300 years in the Ming and Qing dynasty. And we have probably from extracting lead, zinc, silver in those heavily gallianous spherulitic ores. It's not uncommon to find a lot of publications on using this fern for phytoremediation in China. And when we look at to be practical, you know, you can't get all the farmers just to get out of the farms. They need to continue living in the villages. Yeah. So the best way is to co-crop the fern with the maize or the corn, and it does increase the phytoextraction of the metals in co-cropping. Now we have some data here. I'll go through quickly. Metal uptake of this is a particular another hyperaccumulated plant that is from a French study that is also showing very high uptake when they co-crop with another plant like a maize in the field. Now, the phytoremediation is, well, we know is nature-based. A lot of times we do not have the luxury of time and we want to get rid of contaminants quickly, not surprisingly. But, you know, nature-based solutions are good and kind of intrusive by and large, but it does take some time. So we're looking at 5 years of data that is slowly decreasing the soil concentration and the concentrations of for this case, cadmium in the leaves, stems and roots of the maize, as well as obviously, for this case, the fern, the Sedum alfredii that is taking up the cadmium, very high concentrations in the plant. And co-cropping with the low cadmium cultivar, which is the maize cultivar that is taking up low cadmium. We have basically the co-cropping, which I'll show you a picture later. Also, another additional experiment to increase the uptake of the cadmium is, not surprisingly, to add EDTA as a chelator, which grabs the metal from the soil to be available for uptake, and also citric acid. So we add these two ingredients in, and we see an increase in plant uptake because it has solubilized the hard to get metal like cadmium, zinc, lead from the soil to be available for uptake from the plant. The maize will take it up, but of course the hyperaccumulated plant will just soak it up. This is a typical field. So we have had a lot of pot experiments. Obviously, we take it from northern China, bring it to Guangzhou, which is quite far, to do the greenhouse pot experiments. They are successful, and it's started in the field experiments out in the village. Now, we just see some of the these are the paddy soils. The rice is also grown there, and high zinc, cadmium, lead, and kind of alkaline soils also in that area. They've been using the mine drainage, unfortunately, for decades. So it's the metal concentration is elevated. Exactly the same slide. You'll see more data of the soil as well as the rice. The cadmium is elevated in the rice kernel, whereas the lead and zinc seems okay. I mean, there is red, flag red, meaning they're above the standards of the Chinese standards for rice, as well as for the soil for cadmium, zinc for the soil, whereas it's above the rice threshold for cadmium. So they're taking very high cadmium in the rice. As not surprisingly, you have also heard that sometimes the rice that you get from China has elevated metals. And this is a picture where you have the maize or corn, you call it. The fern, the Sedum alfredi, is kind of the bush you see underneath. So it's very nice way to intercrop without disturbing the whole cropping and harvesting too much. Of course, the fern is being harvested routinely so that you would keep having the uptake of the metals over time. And the high concentrations of the Sedum alfredi is dried. Well, of course, it's dried, it's still high concentrations of metal that needs to be incinerated. But the amount that you incinerate of the dry matter is very, very low as compared to digging up the soil to burn it, as you can imagine. This again is some data, a lot of data here, but basically it's trying to show you in a nutshell, when we do co-crop, obviously we have quite high uptake of the metals. Co-crop 42.3 milligrams per pot of cadmium, which is good. But when you add the chelator of the both EDTA and citric acid, you have a enhanced uptake. So it does increases the uptake, which is good. So you would have a slightly faster remediation of the cadmium in the soil, as well as less of it in the maize, right, over time. So it's good amendment. To wrap up, I'm going very fast here. Moving forward, right now we have scaled up to the field trials actually in the villages itself. Each village is about having a population of a few hundred, 250 population, with the very young children also living in there. They have no way to go except to live in the village. They're very far up north. And we are monitoring the cadmium in the maize and the fern. And we are starting, as we speak, to do a human health risk assessment. So I'm assisting them to look at the risk. We intuitively know that it will drop with the decrease of cadmium and other metals in the crop, both in the maize and the rice. And we hope that it will drop to a level that is acceptable in the area. So it will take some time, and that's as good as we can do without having to have them leave the village, which they actually they have no place to go. So the stadium is working well. We also, thank you. We also are then having the experience and expertise exporting this intercropping method to other provinces in the region, like for Yunnan, as well as, not surprisingly, there are actually quite a lot of contaminated metal sites in China. Yeah. and using other crops like mulberry and intercropping with sedum. Yeah. So with that, yes, that's my last slide, I believe. Thank you in collaboration with Prof. Wu of South China Agriculture University. And I don't have time to look at restoration, but there'll be another time for another day, but we can discuss further if you write to me or visit the website. Thank you very much.
Thank you, Mr. Lee. Very nice presentation. Very interesting. Now we have a presentation of Mr. Carlos Herrarte. Mr. Carlos is responsible for Madrid delegation and project director at Little Clean. We'll have a speech about multi-methods, contaminated soil investigation, and form manufacturing. Please, the floor is yours, Mr. Herrarte.
Okay, thank you. I think I can share. Right. Good evening to all the participants in REMTech. My name is Carlos Herrarte, and it's a pleasure for me to share with you our experience in this method soil contamination investigation project. First of all, we're going to talk about our company, just a brief introduction. Let's talk about the site investigation, what the things that we do for this site, the results, and our conclusions. Tema Little Clean Group is an engineering company specialized in environment and safety. Little Clean helps its clients with soils and groundwater challenge in countries like Spain, Mexico, or Peru, and also in other cities where we have a project office. We began its journey as an independent company in 1999. This more than 20 years of professional development, Little Clean has become one of the leading companies in soils and water research and remediation in the countries where we are operating. For this site, we're talking about an old mining site. This is the 2007 aerial photo. This is the historical activity of where the place we're going to make a multi-method study. The project was carried out in a former industrial site from northern Spain with an area of 600,000 square meters. This industrial site was dedicated to the procurement of metallic zinc. The factory activity began in 1960 and was closed in 2005. It is located 2.5 kilometers from the center of the town, and there are residential buildings and industrial park in the surroundings. As you can see here in the corner, the left corner down of the slide, you can see this part of residential buildings and surroundings. This is the aerial photo of the current status in 2021. You can see now there is no industrial activity as dismantling, but they have the debris and a lot of old construction has been there. Soil at this site became largely contaminated with zinc and other metals, lead, cadmium, and copper. These metals contaminate the soil, pose risks to human health and environmental ecosystems. Due to uncertainties around soil heterogeneity and the section of the impacted area and the existence of mud ponds and landfills, multi-method soil investigation was carried out in 2020 and 2021 in 2 phases. The main purpose of this characterization is to characterize the impact of the contamination in soils and evaluate several strategies for the most suitable and sustainable remediation approach. Our site objective, just according to the research of our client, we try to identify all the potential contaminants present in the soil, limit the presence of the identified pollutants in extent and in depth. First introduction to the hydrogeological behavior of the area, it's really complex. Identify potential exposure pathways of the detected contaminant to the potential site receptors, and investigate the potential remediation methodologies by means of pilot tests in the laboratory. The tools that we are going to use and we used before for this analysis are the borehole sampling, installation of monitoring wells, trial pits with our XRF in situ analytical methodology, the chemical analysis in the laboratory, the stratified soil leachate analysis, statistical data processing and interpolation graphic representation with interpolation maps, tomography profiles, geophysical of the depth of the mud ponds, and the tractability tests for the investigation of potential remediation additives. We divided the investigation into phases. In the first phase in July 2020, second phase in January 2021. Yes, in the first phase, we can sectorize all the site because it's a big problem. So we decide just to sector all the parts of the site. First, as a production zone, where are the former activities, the north mud ponds, and the south mud ponds debris. So we decide, as a result of this, try to make a specific investigation about how we can do it. So, for example, in the ponds, only is available to collect mud samples with an auger, just a manual thing, in a safety way. We decide to design a geophysical approach to know the depth of each pond instead of matching drilling. In the debris zone, after the first investigation phase, we decide to reduce the density of trial pits for the second phase due to the lesser presence of heavy metals. As a geological or hydrogeological setting, this is the summary of the work done. The superficial soil level of the production and debris zone is constituted by heterogeneous fields from the industrial activity of the site. This has been identified the presence of low permeability materials, silt, or very low permeability materials under them down. According to the piezometric levels and the groundwater characteristic, no continuous groundwater table was detected in the subsurficial level. Potential deeper aquifer was not investigated. Right here. For the site investigation, a summary of the work done is in the field where you can see we made 200 trial pits with 16 monitoring wells and analyzed samples, 715 soil samples with our equipment, the in situ XRF, 18 groundwater samples, 12 pond water samples for the mud ponds. You can see some picture here. And the chemical analysis, just in the phase one, are TPH and PCB, soil, 17 heavy metals, soil leachate 7 different heavy metals, and groundwater 17 heavy metals and pH. Just to understand the concentration that we have here for zinc, we found zinc in almost all the samples, up to 250,000 milligrams per kilo. This samples with a 27% of zinc due to the former activity of the plant. Copper, the presence of copper is linked to the zinc present, but is significantly less in concentration after 15,000 milligrams per kilo. And cadmium and lead, heterogeneous present, but up to 1,500 milligrams per kilo. You can see it's lesser than zinc and copper. We continue with the interpolation information. We have made 136 interpolated maps to understand how it's defined all the heavy metal contamination at the site. We made 9 tractability studies applied to 4 different types of soil at the site with 4 different additives. And to understand and found the depth of the mud ponds, we make 17 resistive electron tomography. As you can see in our last, in this part of the slide, this is one of the profiles that we can make within a specific company. The results of the interpolated maps has allowed us to delimit the heavy metal contamination. As we can see later in another slide, the results confirm the use of stabilization additives as a value remediation technology. And in the north and in the south ponds was identified the base of each mud deposits. Results. The result we have here in after this investigation is that the contamination is concentrated in the production zone in the upper layers of the soil, except in very specific locations in the production, so the effect by metals has been delimited in depth. Debris zone, this is part of debris zone, significantly lesser contaminated, using mainly associated to waste management process. They have a lot of problem with debris. The integrated study concluded that more than 40,000 cubic meters in the soil zone should be remediated due to heavy metals contamination, mainly, as you can see, zinc, copper, cadmium. The mud pond zones have a total volume around 700,000 cubic meters, and another remediation method just be analyzed in absence of mobilization risk. Groundwater, only shallow groundwater level could be analyzed in this part of the investigation with high levels of pollution in the ponds area of the piezometer monitoring wells that we have installed in the site. There is an uncertainty related to a potential deep aquifer. In this slide, it is presented about the treatability studies results. It is presented a brief summary of the result of the treatability test. One of the 4 additives, the magnesite, has been shown that this is the best option for pH adjustment and to reduce the leachate. Also, concrete has shown very good results. For our next phase, it will be proposed a final pilot test with different combination of additives. This is the part of the treatability study with the magnesite that show the results. So you can see that all the leachate are down. So after the different type of soils, for each different type of soil, we can see that with this additive, it's the best option for the treatability production zone soils, contaminated soils. Our achievements. We consider, thanks to the multi-method approach, this achievement we have got the next achievements. First of all, the presence of other potential contaminants beside metals was discarded, like PCBs or TPH. We have validated the XRF results in comparison with the laboratory chemical analysis. So we can make a lot of analysis in situ, and we can make some decisions in the place during the field work. Identification of heavy metal soil contamination and depth distribution, the detection of shallow groundwater contamination, especially in the pond area, the identification of heavy metal no leaching concentration in soils, aiming to select a specific remediation option like selective excavation. The determination of mud pond thickness, it's important to understand the volume and the composition from the geophysical and metal analysis. Just we can make it thanks to the geophysical. Selection of a specific remediation treatment for each type of area, and the calculation of the soil volume to treat from the interpolation maps. In this slide, you can see an example of one of our interpolation maps, and we can see in the swallow. This is the swallow one, the swallow level, the higher concentration, and you can see it is in depth. We can go to define that the white color is non-concentration of zinc. So the advantage of an integrative approach is that we can remediate option analysis and selection during this work investigation. The key factors have been identified, for example, the necessity of a stability analysis of the mud ponds, and potential setbacks have been prevented or minimized. Thanks to the coordination between phase 2 and the treatability tests, we can advance with the timetable of our client.
Last minute.
Okay. As the last conclusion, we define all this investigation and multi-method approach to select the best remediation solution for the site. After the sectorization, we decide to study all the parts of the site to create the best remediation solution. It's necessary to make some previous work, like dismantling some infrastructure and the mud ponds zone, make some slope stability study, but we have the solution for the production zone, for the debris zone, and for the north and south mud ponds. For example, for the production zone, we can make a selective excavation and the use of the additives. So we have tried the pilot previous test. The debris zone is needed to make waste management and kind of selective excavation just to extract just the soil they have heavy metals contamination, and for the north and south mud ponds to create and install a cover design specific for pads with heavy metals. So thank you for your attention. If you want just to contact with us, there are our emails and the website of our company. Thank you.
Thank you, Carlos. Very illustrative presentation. Now I would like to invite Stephanie to introduce the next speaker. Stephanie? Robert, can you introduce the next speaker, please?
So next there will be Alberto Angeloni and Hans Zielstra. So the floor is yours, Peter.
Screen. Is it? No. This is it. Share. Okay. Is this okay?
Yeah.
Okay, then I start. I have the honor and the pleasure to talk about simple mining water treatment with geochemical technology and minerals. And I'm going to take you to Sardinia for showing an example. Sardinia is an island in the Mediterranean Sea, and it belongs to Italy. It has a very rich mining history. Mining of silver and lead occurred already massively in Roman times, and mining reached its peak in the 19th century with zinc ore mining. Most mines are now closed, and left is a patrimony of mining structures and a lot of waste. The picture you see shows the zinc ore processing plant at Ingotoso, and in the back that hill, that is a hill completely made of tailings waste. Now we're going to the next slide. Sorry. Mining in Sardinia produced about 70 million cubic meters of heavy metal contaminated tailings and waste rock. And after about a century of meteoric water infiltration, the sulfide minerals have completely oxidized into acid sulfate salts, and they hamper revegetation, like you see on the left photo, which is that tailings waste hill at Ingotoso. When mines are flooded, they discharge acid heavy metal mine drainage, and the water flows in some mines at 30 liters per second. The zinc in that water and also in the percolate from the tailings can reach easily concentrations of grams per liter. I think when you start remediating that enormous amount of volumes and that kind of water, what we have to learn is how to control the leaching and, let's say, prevent the pollution without disturbing the mining waste, the solid mining waste, and leave it in situ. Because most of these mines are in remote areas, mountainous areas, there is no power and you cannot have supervision. So you must find a way to control the leaching using passive filtration technology. The best available mining waste remediation technology also has to allow for recovery of critical raw materials, in particular in Europe, where most mines are exhausted now. However, the processing of solid waste for extracting these critical raw materials will reactivate pollution and, let's say, processing the solids will not decrease their volume, hardly will decrease their volume. This photo, what you see, shows a very bad case of tailings waste reprocessing at the historic Balya zinc mine in Turkey. The productive solids, they have been removed, and what is left are some holes with leachate. And the profits from the reprocessing, they went into private hands, and they should, in fact, be used for public funds for the remediation of these very strongly polluted sites. Just also for critical raw material recovery, it's better, let's say, not to touch the solids that much, but try to use the leachate to recover metals. And in this case, when you use filters, you have can have a kind of preparative chromatography, where you can, where the filter can separate the metals in the mixer and purify them so that you can recover them. I'm going to show you an example that we did in Sardinia. This is a site, the Bacalocci mine, that was where the let's say the remediation was designed by Montana. And I had the honor to work for them and under their supervision do the geochemical treatment of the waste and the treatment of the acid rock drainage and acid mine drainage. About 60,000 cubic meters of arsenic lead polluted waste rock was excavated along the river from all kinds of small mines and deposited in the central disposal site. And the central disposal site you can see in the left picture, and the filter treating the percolate in front. And in the right side you see gallery 5. That's one of the mine galleries that produces the largest amount of water, and also that we have treated. So we have an acid rock drainage and an acid mine drainage. The acid rock drainage is very, very concentrated because we have a very high solid concentration and a very low leachate coming out. So the solid liquid ratio is very high. In the acid mine drainage is the reverse. We have a very high liquid concentration and a low solid concentration. So the concentrations of metals are very low, but the volumetric flow rate is very high, or relatively high. Now we constructed a filter which consists of a number of sectors. These are concrete, let's say, concrete basins. And we filtered this filter from the influence side on the left to the effluent side on the right with pellets. At the influence side, we have slowly reacting pellets, and of the effluent side, highly reacted pellets. So laboratory and field column tests showed that aluminium precipitates at low pH and forms a gel, and that blocks the pore space between the pellets at the influence side. It was noted that cadmium was the last to precipitate at very high pH on pellets at the effluent side. So we'll use the different pellets of different size and reactivity. The large and slowly reactive pellets at the influent site, they provide room for aluminum gel precipitation. And the small and highly effective pellets at the effluent site can raise the pH enough to allow for the precipitation of the cadmium on the pellets. The alternative, the septa that are alternatively open at the bottom and the top, they allow for a vertically winding flow, and should the permeability of the filter decrease due to the precipitation of the aluminium gel, we see first a rise of the water level and an increase of the pressure. And if the sectors become blocked, there is also possibility for bypass. You see the results. I plotted in these various graphs the metal concentrations for samples that we took from the affluent side to from the influent side to the affluent side and in the sectors in between. You can see as the pH raises from left to right, the metal concentrations decrease. So this is from left to right is the flow direction also. There are three metals depicted. It's the aluminium, the zinc, and the cadmium. I'll show you the next one. In the photo on the left side, you see three succeeding sectors from the bottom influent side to the top affluent side. And in the photos at the right side, you see a close-up of the pellets at the influent side, where the pore fluid is completely filled with aluminium gel, apart from some flow channels which are still present. And in the top, you see that the aluminium has not yet arrived, and we see that the pellets are much more fine-grained, and there's the precipitation of the cadmium. We have treated successfully about 180 cubic meters of acid rock drainage in 4 months with using 2.6 tons of pellets before the cadmium concentration was higher than the discharge limit. And for the acid mine drainage, we were able to treat 1,500 cubic meters of water in 7 months with 3.3 tons of lowly reactive pellets before the zinc concentration in the effluent exceeded the discharge limit. For both filters that we used, the spent material was inert in a liquid solid 10-to-1 leachate test with deionized water. So it could be a discharge in a disposal site for non-dangerous waste. Now, the idea is that if you have lots of small waters that have to be treated, that you can best do that, or you have to do that with local operators, and you want them to understand what they are doing. Now, the mining water treatment with our pellets is defined by the volumetric flow rate, the concentration of the metals, and the size of the filter that you have at your disposal. And the local operators can readily obtain these values and then use them to prepare the pellets of different size and strengths on site. And by varying the volumes of the different types of pellets in succession in the grade filter, like I showed you before, they can aim for maximum treatment efficiency. And the problem owner, in this case, the municipality of Villa Puzza San Vito, which is responsible for the treatment of the water, they can provide an incentive for maximum efficiency when they pay per volume of water treated instead of the amount of reagent used.
Last minute.
Okay. One needs a practical model that links the treatment results to design of the pellets and the filter, and that model must be fed with the experience of these local operators from many different mining water treatments. And this then will allow for continuous updating of the treatment manuals and best practices which are centrally accessible. Rewarding local operators for innovation should stimulate the sharing of the know-how. The municipality has granted us a new opportunity for another year of treatment, and maybe we can use this occasion to find how the spent pellets material can be recycled a few times before final disposal. We also like to know how the metals that are purified, concentrated, and immobilized on the pellets can be best leached and recovered. And then finally, geochemical technology is about treatment with minerals that better blends into the natural environment. And we might like to investigate in the future how the current filter installations of concrete and steel might be replaced by more natural pellet filters, which can operate on a larger scale and remain stable on the longer term. Hopefully, we will have a chance to report on this in a future presentation. Thank you very much, and keep it simpler with geochemical technology, I would say.
Thank you, Mr. Hans. Now we have a presentation from Beatriz Watts. Please, Beatriz, introduce yourself. What is yours?
Yeah, hello.
Just stop share screen, Mr. Hans, please.
Yes, I'm.
Okay.
I use.
Okay, thank you.
You're welcome.
So good afternoon. My name is Beatriz Watts, and I would like to talk to you about some measurements for sustainable mining operation. I cannot find, okay. So I will go through some introduction of some issues related to mining. I think I will have to start again. Now you can see me?
Yes.
Okay. Actually, I want to stop seeing myself. Anyway.
We are just see the first slide.
Yeah, okay. So I will go through some introduction and issues related to mining. And finally, I will present a checklist of possible measurements that we could take for us people that is interested in land remediation. Mining has a long association with mankind and had played a crucial role on advancement of civilization. So we had to make it as sustainable as possible. For instance, Zambia has one of the largest copper production. Here we can see 2016, but yet 60% of the population in Zambia live on less than $1 per day. This is a case in Guatemala where royalties and taxes paid by the Marlin mine owned by Goldcorp between 2006 and 2009, resulting in a final benefit to a community of 0.5%. Here we can see a graph making gold mine there of Congo and Zimbabwe in relation to United States, Canada, Australia. And there has been some rumors that there is illicit capital flying from undeveloped countries to developed countries. Here a study from Frober and Waris, in which they also show how this illicit capital is flying mostly from commercial transactions through multinational companies, making it at 60 to 65%. Also, there had been a series of accidents related to mining practices, as we can see here in this table. The European Commission reported that from 218 tailings dam accidents, the main causes were unusual weather, poor management of the facilities, and seepage. Here we can see two big problems that happened. One was in Bahia Mare in Romania, 2000. This was an accident in a gold mine. Also, this in the right, we can see a gold mine in United States where the government has to make the clean up because the company was in bankruptcy. Here we can see a disaster in Brazil. This was 2015 due to a problem with the upstream dam rupture and a failure in alarms around the community. Later, there was another accident in 2019 in Brumadinho, for which the Brazilian legislation changed, and this new law is asking to dismantle these upstream dams, who has been related to many of these accidents. This is also a report from the European Commission. In 2011, 2.5 million potential contaminated sites in Europe were estimated, and 45% of these were identified. 50% has been since remediated. And this is by the European Environmental Agency. So this European Commission has created a series of documents, such as the best available techniques reference document for management of tailings at West Ross. And also the UNSCA Convention on the Transboundary Effects of Industrial Accidents has made a checklist for compliance of existing guidelines for best practices. So what is done is that there is a checklist that has to be filled up by the companies, and the government would have to check the index. So this island hazard index is calculated according to 5 main indicators, which are impact of the capacity of the dam, toxicity, quality of the management, natural conditions, and dam safety. So because of this structure, we are going to follow this format for this checklist that we are going to propose today, to expose a series of problems to be addressed and the measure that should be taken. So first, consultations, to ensure that the consultation are fair and that the people involved are not in danger. This is because it has been in Latin America a report of large number of cases of environmental defenders that have been dead. Planning and pre-construction. So problem to address is that in many cases, the insurance is not placed and a contingency plan is compromised because of the money. So if the companies has a mandatory insurance or a protection instrument, such as a captive, it will protect them and provide them with the money in a case of a disaster. Another problem is that the tax revenue is not properly addressed. This is not reflecting really in the local community well-being. Companies have to pay a fair tax, and not only they, but also the subsidiary companies, because they change names in order to you know, to make this, so it should be really everybody in the chain. Or the problem is that mining monopolizes the economy, the activity in the region, and deprive of another industries. After the closing of the mine, the companies, the town is very low in income. So the company should be supporting parallel industries to mining. And I think that the involvement of the community, as in the past presentation, by making them do part of the process is a very good idea. Other thing will be supporting also health and education. Another problem is the overconsumption, which is beyond the carrying capacity of the environment, and we should not emphasize enough in ethical consumption. We should be really working more in that. Additionally, there is another problem that mining operations are located in regions where there are human rights violations, and the sustainability should be really a global enterprise, because we are all interconnected. This is an example, for instance, in Germany, where there is supposed to be zero emissions, and last call was closed by 2018. And Germany has determined to become a green country. However, Germany is a main important importer of coal from the Guajira region in Colombia, which is known to be problematic with the environmental damage that the coal extraction had originated. So we have to remember that this supply chain at the replacement of mineral has to be done globally. Another big problem that we have to address is the planet obsolescence, which is the practice of producing machines that take a certain time of life, and that it had to be replaced because they had only planned to be certain time. And this is just because it's more economically attractive. So that has to be stopped, really. Occurrence of mineral has a limit, and overexploitation causes reserves to become exhausted. So really a mining waste as a resort to assure maximum mineral extraction by reprocessing minerals, by using them as landscape materials, aggregates, salt additives, etc. And if this tiling hazard index is very high, or these substances are in this list of REACH, which is very bad, the danger of the substances override the benefit. So they should be really stopped. This has already happening with the case of mercury. The Minamata Convention came into force in 2017, and it's being replaced, the mercury. In the emergency planning, the measurements that had to be compliant, for instance, is the emergent, in this emergency planning is that the communities are sometimes not aware of these dangers, so they cannot really react in an emergency. So the community must be involved in these preparation drills. And also in this, because they are there in the terrain, they could serve as local witnesses, and they could be monitoring with biological marker or with some sort of kits that could be also helping to see if the weather is changing, if there is any danger in the air, in the water. Another problem in this part of the emergency planning is that there is not basic services for the community after one of these disasters occurs. So It should be really ensure basic services after a disaster. The pollution caused by mining accidents after an accident happen endanger not only the ecosystem, but the services that it serves to the community. So because of that, it should be really implemented a planning of what will be expected before it happened and before it's done, no, the whole process of the planning of the mine. And they should start in the research before it happened, utilizing phytoremediation, phytomanagement, biotechnology, and all these nice techniques that we are going to see in REMTech 2021. After the closure and rehabilitation of the mine, is also recommended to have a live barrier of perennial trees surrounding the vulnerable side of the mine or the tile mining facilities in order to mitigate also the damage. Also during this closure and rehabilitation, because of the CO2 is depleted during the mining operation, the mining should be really encouraging natural reserves so that it's possible also to capture some of this CO2. There have been some initiatives going on with coal mining serving as a CO2 capture. Yeah. This is, for instance, a predominance diagram of iron in these tiling minings of Brazil in the San Marco disaster 2015. We can see here, for instance, that the species that is more big is the iron 2, which is toxic and could be made bioavailable to not only plants, but also humans. But thanks to the factibility that plants and also a vast number of fungi, bacteria, genera had the ability to degrade pollutants, is also possible to take these plants to remediate the site, as we saw in this phytoremediation chat. And we will see probably in REMTech, there is a lot of plants that could be doing this work. This is a little graph of some biomass production in these iron tilings. We can see here the hills.
Beatriz, we don't have much time. We need to finish as soon as
I am
possible.
finishing. I am finishing.
Okay.
I'm finishing. Yes, and then this is like the evidence that is possible to produce biomass even in a very hostile environment. Here is another example by Migorovsky, also in Germany, which uses also this as energy producer. So here I make a little bit of a summary of the use of this phytomanagement. Notice here that there is a biorefinery also in plan that could be implemented. And that is all. Thank you very much. I want to acknowledge some of these people who helped me somehow to do this work. Thank you very much.
Thank you, Beatriz. Now I'd like to invite Mr. Gary Dorland that will have a talk about enhancing ESG at industrial waste, residues, and tailings storage facilities by means of covering with engineered turf capping technology. So, Beatriz, can you stop to share your screen, please?
Mm-hmm.
Beatriz, can you stop to share your?
Yeah, I just, did I stop?
No, we are still seeing your screen.
Okay. I don't know how to do it. It's not store. Okay, yeah.
Okay,
now.
thank you.
Sorry.
Mr. Gerhard, the floor is yours. Thank you.
Okay, think you can see my screen like this, Jose?
Yes.
Can you hear me well?
Yes.
Thank you very much, Jose, and my pleasure today to speak on behalf of Watershed Geo on the topic of enhancing ESG at industrial waste sites and tailing storages by means of engineered turf and solar capping. To today's presentation, the aim is really to raise awareness of the need for capping and repurposing of impaired land or brownfields from our ESG perspective. And the structure is that I will provide you with a short explanation of closure turf and power cap, our main systems. And secondly, to highlight performance characteristics and the ESG impact of these systems. And then I'll wrap up with a conclusion on our view of how these work for industrial waste sites, landfills, and tailing storage facilities. First of all, Watershed Geo, based in the United States, in Georgia, was founded by engineers and landfill operators about over a decade ago. And closure turf and power cap are innovative systems that have been patented and applied across the United States of over 3,000 acres and gradually growing internationally. To explain what we're doing, we're focusing entirely at the cover system of waste landfills and industrial waste sites. We have none to do with the baselining or with the geotechnical construction. We're entirely focusing on optimizing cover systems. As mentioned, a couple of slides on how the technology is working. Best explained how closure turf is working by comparing a traditionally closed cover with a closure turf constructed cover, where a traditionally constructed cover consists of a waste body and a soil leveling layer. And on top of that soil leveling layer, there will be mineral layers and geomembrane sealant layers, eventually topped with geocomposite drainage layers. And then on top of that, there will be like 50 centimeters to a meter of topsoil and a vegetative layer. If we look at the closure turf, the construction of the up into the sealant layer, so with the intermediate soil cover to level out the site, and the sealing membrane is identical. Then on top of the geomembrane sealant layer, instead of a meter of soil, there is a synthetic engineered turf layer, and that's topped up with a specified sand infill to generate optimal non-erosion conditions. Here the three components very shortly. Left you see a picture of the structured geomembrane, profile structured geomembrane made by our partner, the company Agru, producers worldwide. An engineered turf layer, in this case a green one, and a specified sand infill, as mentioned, to go along optimally with the engineered turf to provide optimal erosion conditions. I'll come to the benefit of that from ESG aspect in a minute. First, a slide here on a tailings site here in Chevron refinery residue tailings in California, closed last year, about 80 acres, and fitting naturally within the environment. So here was not a green grass chosen, but a tan brown type of material chosen. So before turning to ESG specific aspects, I'll turn to the other technology of this presentation, being power cap. solar-based solution to go hand in hand and along with synthetic capping of these landfill or industrial waste residue places. Actually, the system was developed particularly to do no harm, to not penetrate or damage any of the underlying sealant layers. So what you're looking at on the left side picture is an anchoring strip, the back side of an anchoring strip with studs or anchors specifically designed to hold with the synthetic, with the blades of the synthetic grass and the underlying sand infill. And in the central picture, you see the top side of the friction strip that is mounted with a rail, and on top of that rail, modular panels are being mounted. So a very lightweight system that is placed on closure turf and is anchored by friction in practice. One advantage of such system is that it's, as I mentioned, lightweight, and it can be placed modular, or slightly tilted or flat laying. And one of the big advantages is that you can reach a very high density of these panels, of the energy yield raised by these panels, where many industrial sites, waste residue sites or landfill sites, but also tailing sites have looked at renewable energy. This system really provides the possibility to generate a higher yield of energy of up to 1 megawatt per hectare these days. And if you look at here a site done a decade ago, which demonstrates that the sector has been really looking at this already for over 10 years. You see a very nice construction, but with not a very high density, so not a very high energy yield. And over the past 10 years, this density has been dramatically increased, and therefore also the rentability, affordability of such systems have much increased. Then turning to the heart and the ESG impact of closure turf and power cap and performance characteristics. As we all know, ESG standing for environment, social and government, and our systems of watershed geo particularly focus on the environmental part, not keeping out the fact that depending on the site location and the strategy and the goals of a company, also social and governance aspects can be influenced. I will mostly address environmental aspects now. And as time is limited, I will only address a few. I'll talk a little about erosion control performance, avoidance of hazardous leachate water, improve of runoff water quality. And I'll highlight a little bit on lowering CO2 emissions, fugitive gas emissions. And finally, I'll address renewable energy generation as with power cap, as it can be done on industrial waste sites. First of all, on the hydraulic performance and erosion control performance, when being innovative, although we're already out there for almost 15 years now, a lot of testing had to be done on all aspects of the system, but also on the hydraulic aspects of the system, as here in a TRI facility in South Carolina, where a 3 horizontal, one vertical slope was being mimicked, and rainfall events were then simulated at intensities of 2 to 6 inches per hour in sequences of 20 minutes. So in between 6 and 15 centimeters per hour rainfall events. And that type of testing led to a loss of soil or sand infill, I must say, at these slopes of about 0.1 ton per acre at this 6-inch per hour rainfall event. Well being within the threshold allowed under APA conditions in the US of 2 tons per acre, but very important if you have heavy rainfall events or erosion events, as you would have in the US, for instance, in the hurricane season. Here an example of a tailings, coal combustion residue tailings located in Wilmington, North Carolina. You see on the left picture, the left downside picture, the erosion channels being created after a hurricane called Florence passed in 2018, where on the right picture, you would see the same site that was covered with closure turf a year later when Hurricane Dorian passed, and almost no damage was done at all to that site, even though heavy rainfall was passing and the site had not even been completely closed at that date. Another example is here, Phosphate Stack. After the company operating the site was seized, and the site was transferred to the government and becoming a US EPA Environmental Protection Agency Superfund site, with a huge problem of acid-rich, nutrient-rich water seeping into the stacking ponds and potentially into the environment surrounding the site. So already up to 700 million gallons of water had to be after treated, and the government was desperately seeking for ways to remediate that site and to do something about it. So decided to choose for closure turf to close off that site. And last year we did the first phase of a 200 acres area closing, where now each rainfall event, heavy rainfall event, we save about 9 million gallons of water at that particular site. And not only water was saved, but also through this method of installation, over 100,000 truckloads of soil were saved and over $6 million in installation cost, as opposed to installing a traditional cover. Talking about the comparison between installing and the carbon footprint associated with installing a traditional cover as opposed to this closure turf cover. This has also been studied by the famous, well-known Kerner family, that are really leading persons in the geosynthetic sector. And they calculated that a traditional soil cover per acre installation would have an impact of little over 500,000 kilogram of CO2 equivalent per hectare, where closure turf would be installed at only 23% of that CO2 equivalent, being 119,000 CO2 kilograms of CO2 equivalent per hectare. So saving 390 metric tons per CO2 equivalent per acre in that particular case, which they studied. Just demonstrating that with another slide. For an acre installation of a traditional cover, about 160 truckloads of soil would have to be transported to site to cover that site in a traditional manner, where with closure turf, only 20% of a flatbed truck for posing the geomembrane and only 40% of a trailer for posing the turf site would be required. So considerable saving on transport movement and borrow soils needed. So I've talked about the quality of water and avoidance of leachate, and about transport movement and borrow soils. Another ESG aspect we influence is in landfills, municipal waste landfills, or industrial waste sites with a high organic component to them, is the avoidance of fugitive or greenhouse gas emissions. What you're looking at is an output screen of a model that was based on IPPC values and the SWIX protocol, which shows that in a standard well-operated landfill with a gas collection and control system, but no final cover in place, still 0.3 standard cubic meters per minute per hectare of fugitive gases emit into the environment, or 155,000 standard cubic meters per hectare per year. Of that emissions or present landfill gases in a landfill, about 50% is methane, and according to the SWIX protocol, about 31% of this methane is oxidized in the cover if no cover is placed. So that leads to summing up a very high tonnage of CO2 and methane gases into the environment. And where I'm going to is that with closure turf, instead of closing large sections of a site, like cells, you would go for incremental closures, as the closing procedure is much easier to do than with a conventional traditional cover. That would require a lot of installation crew to come, but installation of closure turf can be done by a relatively simple crew. So by doing that and making incremental closures, about 70,757 metric tons of CO2 equivalent could be saved in this particular example over a 20-year lifespan period on a 4-hectare landfill. Then back to the renewable part. Another part we'd like to highlight today is the high yield of energy. Here about 0.40 megawatt per acre, or the 1 megawatt per hectare that I refer to, but also the possibility to have a high density of panels installed, not only on the top deck, as you can see here, but also on the side slopes. And with industrial process firms, but also mining firms, having a high energy consumption and having goals set within their own companies to become less dependent on fossil fuels to run their operations, and also sometimes to become carbon natural in their operations, adding solar technology or power cap technology to that industrial waste site, landfill, or tailings, if it's suitable to place tailings, will not only help the company to raise green energy for their own operations, but it could also help them to generate income to maintain that tailings. And as such, instead of only creating a liability, they could make it an asset in cases where it's possible and beneficial. They could make it an asset that would pay for the maintenance, or even as a supply to, for instance, local communities. And with that, I come to the end of this presentation, where we as a company had a closer look at how we impact ESG, and particularly the environmental part, but also to some extent the social and the governance part, by improving water quality, avoiding runoff and leachate, potentially contaminating leachate, by eliminating borrow soils to be used on the cover and less transport movement. I see I miss an S there. By lowering potentially in some sites that contain an organic component, by lowering greenhouse gas emissions, by making incremental closures possible, and by helping to have a clean or green energy supply to operators, owners of landfills, industrial waste residue sites, or tailing sites. By that, helping them to contribute to their governance targets or aims. With that, I'd like to thank you for your attention, and we'll be very glad to answer any question at the right moment, or contact me directly. Thanks, Jose.
Thanks for presentation. Now we have the last presentation of the session with Mr. Hernando Simon from Arequipa University in Peru, that will talk about the importance of evaluating cumulative impacts of the exploration of Cocorroaico project in mining area of Antapacay, Itaia expansion for restoration of Espinar region and South Peru. Please, Mr. Hernando, can you share your screen?
Okay, I have problems with the camera, but I presentation. Can you see my?
Not yet.
No?
No.
Right.
In the meantime, I would like to invite everyone to send questions by the chat for the panel discussion after the presentation of Hernando. So feel free to send questions by the chat.
Now you can see my.
Not yet. You need to use the bottom green.
Yes, I can do the presentation, but
yes.
Just to use this time, there are many questions in chat about the presentations, but they will be available on website of Remtech and also distributed to the attendants. So you have to just wait about 1 week after finishing the conference.
Can you see now?
Not yet.
So, okay, I put my. Yeah, I put a comparative. Where is my? Here. Okay. Now?
Yes, now it's working.
Okay.
Just putting presentation.
Yes, it's only the title. Yes, I very happy to expose you about the problems with the tailing damage in south of Peru. This presentation is a result of research about in the mining zone in Quintaya and Tapacay mining zone. I demand your excuse because my quality of diapositives is very bad because I have problems with my laptop. This is the panorama of the zone, and this is the outline of my presentation. An introduction about the general location of the mining area, what is the context, a mundial context of tailings dams, what is the problem with tailings dams in Peru, the characteristics, the features of the tailings in the Espinar area. I talk about the impacts and environmental, economic, and social impacts. What has been done here in Peru? We made some studies about stable isotope and radiotracer studies, and we finish with conclusion. This I show in these diapositives. I put my. Okay. I put in these maps. We show the location of the mining area in the southern region of Peru. It's in the department of Cusco, province of Espinar, alongside the extinction of the operations in activity. On the next slide, we show in the left side shows the different districts involved in the mining environment. And on the right side, you can see the detail of the entire beneficiation zone, the Tapacay operation zone, and the new project called Corocuhuayco integration. In this diapositive, I show the statistics of tailing dam failures according to ECHO in 21, considering the type of either failures, accidents, or groundwater contact, and the hatching symbology for active and inactive dams. The number of incidents reported in Peru was 30. On the left, according to the stage of the operation, and on the right, the cause of failures, either in the stability of the slope, earthquakes, and or overload. And this graphic, I showed a statistics of the failures in the tailings dam, showing the increase in severity between the period 1940 to 2010, separated by decades. The degree of severity is displayed. The tailings in Peru. The number of tailings in the Andean zone related to mining operations is a latent danger. And this table shows the failure statistics in the tailing dams in Peru up to 1981, according to Interpolated, indicating the main causes, earthquakes, the consequence, and the current state constituting environmental liabilities. And this slide, the information is updated until 2019. 80 no faults causes earthquakes and deficiencies in constructions. There is no database of dam failures. It has only been compiled for information in the media. The sinistrality rate of dams in Peru is constant the last 70 years. It's important to consider the geographical conditions in the mountain region because we have dry climate, strong sunshine, heavy rains, constant winds, and the transport of dust from tailings dams occurs and can contaminate large areas. The tailings in the mining area of Espinar. I show the locations in the satellite image with the location of two tailings dams in the Espinar open pit mining area, where the project areas are delimited with red lines, the rivers whose waters have been polluted. This is the detail of the Winnipeg Dam, where the largest tailings collapse occurred in several years, from 2005 to 2010. The green dots indicate the tritium isotopic radiotracer monitoring stations in the left side of the diapositive. It's important to consider the geology because we have outcrops of sedimentary rocks, limestones and sandstone, and also batholithic rocks. The big problem is with calcareous rocks outcrops because it's affected by dissolution phenomena, the karsts. Occurrence in bundles also occurs the calcareous rocks in bundles, chaotic sedimentation, or lithostromes of various sizes when carbonate platform collapse. What is the background of these two dams? The difference between the two dams is 20 years. Camagmayo is the 1909 and Corocohuayco is 20 until 23. In the second tailing, the regulation required the presentation of AEA, but it was not learned from the experience in the operation and impacts of the first dam, nor was a quality study made reliable with the required rigor and the degree of detail in the geological map. Now we have a lot of impacts because we have several collapses in the tailings dam through the dissolution structures, cavities, and caverns, causing the infiltration of several millions of meter cubic of tailings, contaminating the aquifers in the Cañipía and Salado rivers. An ecological disaster that was hidden, camouflaged, and the problem was never revealed. The works of the detection of the collapsed seats, the inventory and quantification of the filter of the tailings in the two dams have never been done. The waters for more than 15 years have high content of toxic heavy metals, which has affected the health of people by ingesting contaminated water and also the source of the water for animals. What was done in Peru? In 2013, the INGEMET study recommended the analysis of stable isotopes and with isotopic radio tracers. And also it was necessary to do a hydrochemical and isotopic study. OEFA is an institution, is the inspection body, contracted several studies, but the lack of expertise from both IPEN, is the Institute of Nuclear Energy, led to the objectives being unclear. The studies, the first only made the analysis with stable isotopes, and in the second, the tritium radio tracer was recently applied. Among the main problems for the studies, there were delays, the schedule was not strictly adhered to, the applied methodology had deficiencies, and finally the results were not well interpreted. More than 7 years have passed and the study has been made available. In summary, despite the scientific evidence of tailings filtering, the Peruvian state has not been able to reveal the source of the contamination of the water with heavy metals, nor to enforce the rights of the community members who have been seriously harmed in their health and in their means of survival. And the next 3 slides show the results of the monitoring. In this, we show the curve resulting from the monitoring, and this one, the evolution in the residence time of the tritium, and this is the graph that shows the presence of tritium throughout the 12-month period of monitoring. There is a clear scientific evidence of tailings infiltration from the Winnipeg tailings dam. What is the current situation? The company does not recognize EcoSeed and has implemented a closure process covering the surface of the tailings with earth and planting natural pastures. The situation is critical since the dispersion of pollutants continues. The waters are still polluted and there is no water supply for the populations, nor ability of water resource for livestock. The serious consequence, the residents are being secretly forced to leave the territory, being a clear violation of the most basic rights. What is the perspective? The Strata company, they want to continue exploiting the area with the development of the Torocohuayco project, which in the exploration stage has also caused a serious damage of the two surrounding communities. The cumulative impacts in the area have not been studied. The company has implemented a management system which does not take into account the existence of the environment liability or its environmental recovery.
Last minute.
The conclusion. Okay. Yes, I finish with this diapositive. It is crucial to urgently plan the restoration of groundwater and soil contamination in the hydrographic basin and make a remediation plan that considers the reduction of groundwater heavy metals contamination with wells programmed with technical criteria. It's advisable to start the process of restoring ecosystems that have been degraded in the areas of mining environmental liabilities, the PAMs, affecting the productivity activities of the population in the 15 communities. Thank you very much.
Thank you. So now we have a final discussion. We have some minutes for questions, and we received some questions here at the chat. The first question is to Carlos. Considering the high zinc concentrations, it was considered possible of metals recovering before the remediation of the area?
Yes. We're just talking with some waste management. So we are just testing if with this zinc concentration, we can make some kind of recycling this kind of soil, because there is some concentrate of zinc in some part of this kind of soil. The first option will be to in Spain, we don't have a place just to recycle this kind of methods on soils, and it's going to be to go to some parts of Asia. But we are just studying this problems about sustainability, the quantity, and if other kind of metals could be a problem just to recycle. But this is an option that we are studying, just to recycle this kind of soil. Thanks for the question.
Okay, thank you. The next question is to Mr. Dortmund. The question is, what does power cap to the contaminated site?
Power cap's not been designed to remediate the site. Power cap is a renewable energy solution to be placed on top of closure turf. And closure turf, as I highlighted in the presentation, avoids risk like erosion and leach it out of the stacking. But power cap, the solar solution in itself, is not a remediation solution. It's a renewable energy solution.
Okay, thank you. Robert, do you have any question? You need to unmute.
Yes, okay. So I don't know if Lee Charles is still available due to
No, I'm sorry. Mr. Charles just sent a message telling that past midnight in Singapore. Then he must to leave. We have people worldwide here, so we have problems with time zones. Stephanie, feel free if you
Yes.
have any question.
I have a question for Mr. Dortland. So you showed a lot of comparisons, with regular turf. I was wondering if you also had a cost comparison between your closure turf and using regular turf.
Yeah, and certainly many references done over 3,000 acres now installed. As you will realize, each and every site is different. So the transport movement to every site is different. The construction cost and the design cost, geometry of each site is different. So it's very site specific. What we see is that many of our installations, like the one I showed at the APA Superfund site in Mississippi, the gypsum stack site, that alone saved $6 million in construction cost as opposed to the traditional cover. So anyone who'd like to have more information on that particular cost comparison, be it the APA site in Mississippi or a traditional landfill or a industrial waste site, please contact me or through the REMTech organization, and we'll be happy to provide you detailed cost analysis information.
Okay, that would be interesting. Yeah, you have an interesting product, and I can see its advantages to natural turf in situations where you have extreme weather, like extreme rainfall.
Yeah, thank you. Yeah, agree.
Mm-hmm.
I do have a question to Mr. Hans. Mr. Hans, can you talk about the composition of mineral pellets?
Can you hear me?
Yes.
Well, not exactly, because that's let's say a trade secret. But
okay.
what I can tell is that these pellets can be made from let's say industrial materials readily available on the market, and it's just a matter of mixing them in the proper concentrations, and that can be done on site. But the principle I showed, let's say that you start such a filter with lowly reactive pellets and then end with finer grain to highly reactive pellets, that holds for all kind of pellets. You can also use in the beginning, let's say, just carbonate fragments, and at the end something else which is very reactive. Yeah, that's the only thing I can say at the moment. So if you want to use the pellets, then you just contact us, and then we can see how to do that. But also important that I want just to stress is the last thing is that I think it's very important that these things can be done locally by local operators, and that the problem owners can do it themselves. And certainly in Europe, where you have many different countries, every country wants to do it themselves, and you need a technology that everybody can use everywhere without let's say depending on one company.
Okay, thank you, Mr. Hans.
Your pleasure.
Stephanie and Robert, any more question? Oh, I have a question here from Rita Salgueiro to Mr. Hans. Does specific surface of the pellets have influence?
Yes, let's say we make the pellets bigger to have a lower reactivity. They are porous, so if you have bigger pellets, they have a lower surface and then have a lower reactivity. Make the pellets smaller, and we can also increase the reactivity. They are more reactive, and that low reactivity you need, for instance, for the aluminium. You don't want to have a high reactive pellet at the beginning, because then when the aluminium enters, it's immediately going to precipitate and it fills up your pore space. And that's what you don't want. You want to have a large volume of lowly reactive pellets, so that that whole aluminium precipitating in half a year, for instance, is distributed over a large part of your beginning of the filter.
Thank you, Mr. Hans.
Pleasure.
Stephanie.
Yes, okay, so I was going to ask Charles Lee about this, but since Beatrice also presented phytoremediation as a solution, I was wondering if she could talk about the time frame for that sort of remedy at the mine sites, and what her experience or predictions might be for longevity.
Hello. Yeah, I think it's, yeah, thank you. I think this has to be really start from the plan of the site, and this is because it's a very long time. These plants can grow. For instance, this one that was with the essential oil, they were about 6 months. They are very quick growing, but then for an industrial purposes is a little bit different, no, because you want a lot more production. There have been studies with actual big numbers, but these grasses that I presented, they are very quick, actually, quick growing. The problem is that they don't take as much metal as it probably a big tree will take. No, but there have been very good studies with sesamoides, no, with the citratosesamoides and all these essential oils. Yeah.
Okay, thank you.
So we have a few minutes to the end of this session. We have space for more 2 questions.
Could I ask a question? Also about remediation with phytoremediation. Recently, we had here in where I live here in the south of the Netherlands, enormous floods by heavy rain and very old mining tailings that everybody forgot about. They were washed away and exposed again. And the treatment that we want to suggest is to do phytoremediation. But let's say you can read about phytoremediation in various areas, for instance, the Chinese area, but the same plants you cannot find over here. And if you want to do phytoremediation in a nature reserve, how can you do that? I mean, what plants can you use, and can you introduce them into your, let's say, nature environment? Because they're exotic, as I understand now.
They are actually not that exotic. They are plants that are the first to colonize when there is very hard conditions. They are like first colonizers. So they had been found around the world, actually. There is a very big list of plants. I could perhaps pass you some information later.
Yes.
Yeah, there are this one, for instance, that I'm talking about, this with this Citratus sesanoides. This sesanoides is very a high rate of growing, and even in Germany, I had seen that it's been used in some ecovillas. And what they do is that they put it in the place where they remediate the solid wastes, the sewage. So they plant so the terrain become better because they are capable of absorb all these difficult oil-wise, no, minerals. So yeah, there is a lot of research. I am sure that during the week there will be a lot of examples, successful examples.
Thank you. And I have a question about the soil, about the turf. Your company is 15 years working on this. What is the, let's say, the guarantee you give? How long does your cover remain?
Yeah, thanks, Hans. Actually, yeah, very true question, right? Good question. Since 15 years, so a lot of testing had to be done, and today was, of course, very limited. But one of the main points to be tested and evaluated is lifetime. Engineered turf is often seen as turf that you would see on soccer pitches or on landscaping applications, but this is really an engineered turf that has the characteristics to last very long. So one of the main tests we've done in lab, but also in Arizona, is to define the half-life value in strength. So the tensile properties of the actual exposed component of the system. And the exposed components is the grass blades. And so what we've done, we've tested that, and in intervals of 2, 3, 5, 7, 10 years, you're taking samples and you're testing the strength, the remaining strength in that particular sample that represents the synthetic turf. And what we found is that the half-life strength value is reached, it's an extrapolated value, which is reached after 176 years. So with that half-life strength, you can still go on for a very long time, but at least it's a good indicator of the longevity and sustainability of that or lifetime of that type of material. So it's there to stay for a very, very long period. And also washing away of elements is very carefully studied. So it's an engineered product, as mentioned.
Thank you.
So thank you, everyone. We're in the end of the session. Before closing, I also like to invite who is interested to coming back tomorrow for section 5, where we're going to have a very interesting presentations regarding bioremediation and phytoremediation in agricultural, industrial, and also in military sites. So thank you very much for your participation. It's an honor to be here. Was a very rich discussion.
I want to thank, while I'm sharing my screen and seeing the program of tomorrow, and reminding not only session 5, but the session of ISTM tomorrow afternoon European time, and in the morning of America, of course. And you see, tomorrow we have a big and impressive program: bioremediation, then oil and hydrocarbons, and then on the parallel, maybe you are more interested, Jose, on high resolution site characterization. I know that you worked on it with your project with the Compagnia Siderurgica Nacional.
Yes.
And then in the afternoon, alternatively to Stephanie, but I will be with Stephanie, I have to say, we have also the innovative digital and smart characterization techniques tools and the circular economy, how to apply it in the context of the next generation use. So I hope tomorrow we don't have problems that we had this afternoon. And I would say thank you again to not only to chairs, but also to all the speakers, starting from Charles, Carlos, Hans, Beatrice that did a great presentation, and Gerrit and Hernando. Thank you very much for this session. I'm sure that all the attendants go home with some new knowledge about the mining sites. Thank you very much.
Thank you.
Thank you.
Thank you.
For the opportunity.
Bye. Hope to see you tomorrow.
Thank you very much, Ed.
See you tomorrow. Bye-bye.
Bye.
Bye.
See you tomorrow.